C2274, and this is our video for the U.S. Open Division. My name is Arturo, I'm in 10th grade, and I am the driver, builder, and programmer.
My name is Andrew, I'm in the 10th grade, and I am a scouter/builder.
My name is Ryan, I'm in 10th grade, and I do research and notebook design for our team.
Alright, first we'll start off with the base. Our base is basically a holonomic X-drive chassis using 2.5-inch Omni wheels as the wheels. The reason we went with this design is so that our robot could go in all directions, including side to side, which is really good for maneuverability. It can, upon going forward, backward, side to side, it can also go wrong. It can also go side to side, making this easier to pick up balls and adjust our angle for aiming.
For our intake, we have a static chain right here to create pressure for our dynamic chain, bringing the balls up. We also have these down here to grip onto the balls to rifle them into the intake here. The dynamic chain and the wheels down here go in separate directions, making so that it goes inwards and upwards at the same time, or down and out. We're just like, we got inwards like this, and then we have outwards like this.
So moving on to our gearbox and flywheel. Our flywheel is probably our most impressive part of our robot, and saying that is because our flywheel is able to have the ability to score from the starting tiles and at midfield range. So this is all possible due to our two speeds that we've been able to program in a robot. Our first speed makes it from the half tiles, and then our full speed gets it from the starting tiles. So then, this is all possible due to the fact that we've improved our previous gearbox, which used to be about a 1:21, and now it's a 1:43. And this is possible due to our 4-motor drive instead of 3, and that also connects to its own power source, which is a spare battery we have. And what we've done for that is we've engineered it so that we have 2 large 1-to-1 gears at the base, so that way all motors are able to go into that first set of gears. So we have full power when we're using our flywheel.
As for the programming, the toughest part of the programming would have to be either the base or the motors for the gear. The reason behind this is because for the motors, you have to make sure you program the motors correctly. If not, they will go against each other, and they will either die out or just break or won't work anymore. And the chassis was difficult because you have to make the wheels go in a certain direction, and if you did this wrong, your robot would just spaz out and not really be able to control itself. But you have to make the wheels go inward when going sideways or forward when going forward, and that's probably the most difficult part of the programming.
So moving on to our notebook, we start off our ideas with basic research and different base designs. So this was our first ever idea of having a standard Vex base, and then obviously we didn't agree upon that and we've gone to different ideas. This one has exposed wheels and this one has enclosed. We had different pros and cons for each one. We've also thought about using an H drive, but we've decided against that for similar reasons. And eventually we've decided on using our polynomial drive as we have right now. And this is a more detailed sketch of it to show the structure and everything. And then we've also researched different intake designs about intaking the balls, using the wheels that we have right now and other different types of things. And we've used different sketches on how to get our ball from the intake to the flywheel, and we've stuck with the one we have right now, which is this design here with the static chain and the dynamic chain in the back.
So, for our future designs and improvements, we plan to have a slip gear right here, making it so that we don't have to rely on just our flywheel to score high goals from the starting tile. We can have a slip gear and then have more accurate and more common high goals. We also plan to change this possibly to plexiglass to create more of an open bottom.
So our main strength would probably have to be our flywheel, and then The toughest part of a robot would also have to be the flywheel in general. excuse me. Our community involvement has been attending different competitions and helping out there. We've attended to Make a Million competition, and we've also attended to a Mars competition to volunteer and help out with whatever they need there. Excuse me. So in conclusion, this is Team C2274, and this is our robot.